In this demo, we will first demonstrate that 5G user devices, also known as user equipments or UEs, are currently not capable of detecting threats posed by fake base stations. In commercial network, a base station broadcasts frame synchronization signals, master information block and system information block messages periodically to advertise its presence to users in its cell. The cellular device first scans the frame synchronization signal in the frequency band that this device is allowed to operate on, and for each frequency, it prioritizes the strongest among acceptable cells for connection. When this cell is found, the UE will camp on this cell and start cell resurrection procedure if required. After synchronization, the device decodes MIB, gaining essential information to interact with the network. Subsequently, the device decodes various SIBs for detailed network information, which guides it to connect to the network. Since these messages are broadcast without encryption and authentication, an attacker can easily impersonate a legitimate base station by mimicking its parameters but with a higher signal strength. This method effectively lures cellular devices to connect to the fake base station. Once connected, the attacker can exploit this connection by sending malicious, out-of-order messages, disrupting normal communication, and potentially compromising the device's security. Now let's go to the demo of Numb Attack. Here, the attacker has set up a fake base station using software-defined radios and open-source cellular stack, and the victim device has been attracted by the fake base station. After that, the attacker will inject an out-of-sequence Authentication Reject message, which does not have any integrity protection and encryption. Authentication Reject message indicates to the UE that the authentication procedure has failed and the UE shall abort all radio activities. Upon receiving this message, the victim UE's radio will be completely frozen and remains in such a numb state until the user restarts the device or reinsert the SIM card. This kind of denial of service attack can become particularly problematic if the device is deployed in DOS mission, but lacks any defensive mechanisms. Now we are going to demonstrate how our ZTX 5GThreatDetector can detect the previous attack. With the ZTX ThreatDetector, when the fake base station performs the same attack, the ZTX monitor running on our device can detect the attack and gives an alert to the user about the potential threat.